So let's work on some net ionics. Hopefully y'all will breeze through this. Um, Again, there are some funny rules, and maybe hopefully we can figure this out. So let's start off as we kind of did last time. That's just writing the generic honors chemistry formula. And this first one is kind of difficult because there's something special about it, and it's this carbonate. Okay, we're going to talk about it. But there's a key word, and it's the first word. It's solid. So circle that. So it's got to show up. So NH4 what? Well, this is a plus. This is CO3. Very good. NH4 2CO3. Okay, so this is where it gets weird. Carbonates, when they decompose, they have a standard thing they break down into. And why they do this, to be quite honest with you, I don't quite know. Every time a carbonate decomposes, it always breaks down into CO2 and water. Every single time. Why? I wish I had a good answer for you, but I just don't. Okay, do what? It's not necessarily a type of combustion, it's just what it does. When carbonate breaks down, so we know there's a carbonate, so we can automatically get this in here. CO2 plus H2O. So the next thing, to be quite honest with you, should be easy to see what happens. Okay? What happens is one of these H's sticks on to two of those O's and makes what? Water. So what's going to be left here? NH3. Very good. So you're going to be left with NH3. NH3. Now, last and final question, is it balanced? No, it's not. So if we want to balance it, we can put a 2 right there. Now, to be honest with you, we can't cross anything off. There's not any group 1 metals. There's not any strong acids or strong bases. That's the answer. That's it. So this is the answer. So NH4 2 CO3 goes to CO2 plus H2O plus NH3. Now, very good, thank you. And then come back in here and balance it. So let's talk about double I. Predict the algebraic sign of delta S. And here's the next big thing. What is that next big word? Explain. So you can't just say plus or minus, right? Now this should be simple. What is the state of matter of this? Solid. Gas and a liquid. So this is a gas. This is a liquid. That's the gas. What is delta S again? What is entropy? What is entropy? What's entropy? It's disorder, essentially. Does nature like your room ordered or disorganized? Disorganized. So is it becoming more ordered or more disorganized? It's more disorganized, so is nature happy? Yes. So delta S is going to be positive because a solid is turning into 3 moles of a gas and 1 mole of a liquid. Now, why did I say it like that? Why did I say, hold that thought. Or don't pause. All right, so again, why did I say it's 3 moles of a gas and 2 moles and 1 mole of a liquid? Because you have, why is this taking so long to swap? You have 1 mole here and 2 moles here. So that is 3 moles of a gas. Wait, excuse me. Okay. I did make a little mistake here. And this is not water liquid. It's water what? It's water gas. I'm sorry. So you're technically not 3 moles of a gas. You're what? Your 4 moles of a gas. Okay, 4 moles of gas from a solid. That's where it's coming from. I wouldn't even mention it. I would just say you're going from a gas to a different amount of moles from a solid to a gas. Say that again. Yeah, it's one mole of solid. All right, so let's write the honors chemistry equation with that. Hey, Jack, there are each one of those is what we're working on. Those 3 sheets right there. All right. Now, just for space, guys, if you want to write it at the bottom or write it on the other sheet, I'm gonna put it right here. Do not fill in this box, so I'm gonna write it. So the regular honors chemistry equation. What is important about where it says chlorine gas? What do you need to do there? If it's a gas or a solid, you circle it. And since it's circled, what do you have to do with it? You have to write it in the equation. Now, please don't mess this up. It's not an ion. It's Cl. Why is it Cl2? It's diatomic. Please don't mess that up. Iodine, chlorine, bromine, fluorine, nitrogen, oxygen, hydrogen. All those are diatomics. And it is mixed with something called KBr. It's going to yield something. Now, when we were in honors chemistry, we learned that this is what type of reaction? Single replacement. Well, we had to look and see if this was more active than the other. Do y'all remember the activity series? Well, these are the halogens. The halogens are based on their part in the periodic table. So fluorine is the most active. Iodine is the least active. So is chlorine more active than Br? Based on where it's at on the periodic table. It's above it, right? So since it's above it, Cl can come in and kick Br out. Okay? That's what it can do. Now, in AP chemistry, all reactions work. What's wrong? Yeah, I'm writing the honors version right now. Remember, I'm writing honors version. Because we always write honors version. Now, what's this going to turn into? Plus what? KCl. Now, Br2. Very good. Why is it Br2? Diatomic. Again, please don't mess that up. Now, since we're now in AP chemistry, we can cross off something in this. What can you cross off? Why can you cross off K? It's on both sides, and its oxidation state does not change. What was the oxidation state of chlorine when it was a gas? Neutral. What did it go to? Negative. What was Br here? Negative. What did it go to? Neutral. So did its oxidation state change? Yes. K stayed at a +1, +1. Plus, K is a group 1. What do all group 1s do? Dissolve. All right. So let's write this how it should have been written. Cl2 plus Br minus goes to Cl minus plus Br2. Now, is it balanced? No. This is a simple one to balance. 2 here, 2 here. And you're done. 2 here, 2 here. This is really easy too. Oxidation numbers, you better get these. What is the oxidation of chlorine before the reaction? Well, before, what was it? 0. Any element in the atomic state is always going to be 0. And after, what was it? -1. Now, where did that come from? Cl minus. Cl minus. Okay. Any questions on that? So, to me, that's a simple one. For real. If they give you one like this, you better be screaming for joy because you just, plus this right here, you should have got 5 points. 5 out of 15. You're well on your way. Even if you blow the other 2, at least you got 5. Okay? All right. Yeah, there's only 3 of them. There's 3 equations and 3 qualitative. 1 qualitative per each question. So every this part is worth 4, and that's worth 1. Right. So let's look at the last one. A small piece of sodium. Here's the key word. Small piece. Since it is a small piece, it's a what? It's a solid. So in a solid. It's placed in a beaker of distilled water. So what are you going to add to it? H2O. Now, have any of you ever done this before? Very good, Lane. It's gonna make NaOH. So what's gonna? But see, let's look and see what happens. Anytime you put a metal in a water, you're gonna get a metal hydroxide. Okay, this is that type of reaction. This is one of those things that you just have to know. A metal plus water yields a metal hydroxide. Very good. Yes, I'm getting there. Very good, Taylor. Plus hydrogen gas. All right, so now, metal hydroxide. So this is what we're going to, again, this is going to go in this box. I'm just using this for space. Metal hydroxide. So what would that metal hydroxide look like? Well, in honors chemistry, NaOH, and it's going to make the hydrogen gas, so plus H2. Now, we're not going to worry about balancing yet because the balancing may change a little bit. Taylor and Lane, you have both said it, and this is very important. And if you are listening at home, please grasp this concept. What is this that's important? Strong base. This is a strong base. Anytime you have a strong base, you always have to write it separated. You always split them into its ions. And it should be a common sense approach. Why? Because what do strong bases do? Dissociate what? 100%. Are so they ever going to be together? Never. If you write it together, it's wrong. You will not receive credit for it. So this is the way you must write it. Na plus H2O goes to Na plus OH minus plus H2. That is the only way they will accept this answer. Yeah, it would help to write the water as HOH as a matter of fact. But here's the deal. It's not balanced. As a matter of fact, Lane, I'm gonna erase this and I'm gonna change it to HOH because it's gonna help making our equation balance a lot easier. So let's look at it. You have, and I'm gonna show you this is how it's gonna make it a lot easier. You have 1 Na, 1 Na, 1 H. Treat this as it's a hydrogen ion. How many H's over here? Which right here you've got 2. But how many hydroxides? You've got 1. So I need to stick a 2 right here. But what did that just do to my hydroxides? It just gave me a 2 right here. Now, this is why I don't like splitting them, is because here's the problem. I know it looks balanced, but on here, they have, I'm just going to show you, and I'm going to show you why. Why do they have that? Say that again? Got to balance the charges. Very good, Lane. That's why. So it's hard to recognize that. Most people say, oh, I got 2 OHs, I got 2 OHs, I'm done. That is exactly why. You must balance this charge, because if it was a 1, there'd be how many pluses over here? There'd be 1 plus, and there'd be how many minuses? There'd be 2 minuses. So you have to balance the charges. Very, very good job. Very good job. So, in this case, since it's a part of the strong base, you have to write it. Again, Joe, that's only for strong bases, okay? Just make that note for strong bases, write them dissociated. So what I would recommend doing is what you have is you have atoms, you have charges, and I would even write this just to get in the habit of it, and electrons. Now, are there any electrons in this particular equation? The only time you're ever going to have electrons is in electrochem. That's the only time you'll ever have to balance electrons. But do your atoms balance? Yes. Well, when you got to the charges and you did not have this 2 right here, would your charges have balanced? No, right? So until you scratch it off, you need to double check it. And of course, the electrons will balance because there's not any until you get to electrochem. Okay. The reaction is exothermic, and sometimes still flames are observed as the sodium reacts with the water. Identify the product of the reaction that burns to produce the flame. Hydrogen. What is the only thing that is combustible in this entire formula? A hydrogen gas. That's the only thing that's combustible. Will the Na turn into flames? No, that's a solid. Will water just spontaneously combust into flames? No, I've never seen that happen. I've never seen sodium hydroxide just boom, turn into flames. But have you ever seen hydrogen gas blow up? Yes. Have you ever heard of the Hindenburg? Please tell me yes. The Hindenburg blimp was filled with hydrogen gas, right? Remember the big, looks like a big, what are those, a Zeppelin, but not the big, a blimp. It's essentially a blimp, but it was filled with hydrogen gas. Well, guess what happened to it? It got struck by lightning. The whole thing just blew up in midair. Yeah, it was something with static, yeah. Do what? We have blimps, but they're filled with helium. They're not filled with hydrogen. They learned real quick after the Hindenburg, don't put hydrogen in it. You'll blow up. Okay. So hydrogen is the reason. Now, here's the good part. All you would have to do is what? Identify. Here's another key word. The product. Read it for what it's worth. It has to be one of these two, right? Well, sodium hydroxide, essentially. Okay? But a base isn't going to blow up. It has to be the hydrogen gas. But do they ever say justify or explain? So what do you have to put? H2 or hydrogen gas is what I would put. So I know this one would have been rather difficult because of the base unless you knew that rule. But I think you could have at least achieved this, and you could have definitely balanced it, and you should have gotten the double I part. So you're looking at possibly 2 out of 5, 3 out of 5. Okay, that's pretty good. It's pretty good. All of question 4 is worth 15 total points. Each little letter, B, A, B, and C, are worth 5 points apiece. Okay. Yeah, you get 1 point for the reactants, Joey. You get 2 points for the correct products and 1 point for balancing, and then you get 1 point for the qualitative question. All right. Good. All right, so that's good. That's the 2007 exam. Let's go back and look at a few other ones. Now, you're going to notice a huge difference in this next two, because look at the year, 2004. They changed it up. Ours are not like this, but it's still net on it. Look at what you had to do. The score is 15%, but look what it says. Pick any of the, how many? 5. So you only had to pick 5 of the ones that were listed to do. I kind of like that. That gives you a good shot, right? But let's do some of these. Do what? Yeah, absolutely. But the problem with that is it's time consuming. You know what I'm saying? So you don't want to waste time like, all right, which one can I do? Which one should I do? So that's the only bad part, is that this is time consuming. All right. So cadmium metal is placed in a solution of tin-2 chloride. Now, as soon as it says metal, what is that telling you about it? It's a solid. So cadmium, I wish I could, here, let's do this. CD. CD is in dog. All right, so CD, and it's neutral, is placed in a solution of tin-2 chloride. So let's see what happens. Tin-2 chloride. Let's write the honors version. That's SnCl2. What type of reaction is this going to be? Single replacement. So now you're going to have cadmium, but here's the biggest problem. It doesn't tell you what charge cadmium is. You better know it. Silver, zinc, and cadmium are always one charge. Silver was a 1+. What were zinc and cadmium? 2+. Cadmium was always a 2+. So it's CdCl2 plus Sn. Now, cadmium went from neutral to a what charge? 2+. SN went from a 2 plus to a neutral. What did chlorine go from? Negative to negative. So did it change? So what can you do to it? You can cross it off. So chlorine has got to go. Chlorine has to go. So really, essentially, this could be a redox reaction, which it is. It is a type of redox equation. So let's write what you would have written on the AP exam. CD plus SN 2 plus goes to CD 2 plus. Again, make sure you remember that cadmium is always a 2 plus. And zinc is always a 2 plus, and silver is always a 1 plus. Okay, charges are balanced, very good. Atoms are balanced. Of course, you don't need electrons. Okay, any questions? All right, so let's look at B. They keep whiting this box out. Ooh, that's not good. All right, magnesium pellets. Oh. When it says magnesium pellets, what is that telling me? It's a solid. So it's Mg solid is placed in a 1.0 molar hydrochloric acid. So it's going to be HCl. What type of reaction is this? Single replacement. So now we're going to have MgCl2 plus what? Just H? H2. Why is it H2? Diatomic. Very good. Now, Mg went from neutral to a 2 plus. H went from a plus to a neutral. Chlorine went from negative to negative. So what can you do to chlorine? Get rid of it. This is almost the exact same question, right? Only thing that's changed was cadmium and tin. Bingo. You get rid of chlorine because it's exactly. So how would you? So there's several ways to look at it. So the chloride ion was also soluble. The hydrogen ion. So Mg plus H plus yields Mg C. Excuse me. That's not right. Mg2 plus H2. Last question, is it balanced? No, 1Mg, 1Mg, 2, or 1H, 2 H's. Get it to H. Now, what's the last thing you always want to balance? Charges. Well, you got 2 pluses and 2 pluses, so it's balanced. Any questions? All right, let's move on to C. Again, the more of these you work, I promise you, the better at it you'll get. All right, so sulfur in its standard state. Now, we need to talk about sulfur for a second. How would you write this if it was sulfur in its standard state? I know, it is, but there's this thing called an allotrope. Very good, Taylor. It's S8. They will, but here's the deal. You're in luck. They accepted just S, so you're okay. I would have never put 8 either. They have both of them. It says S8 or S, so you're okay as long as you balance it properly. So you're okay here. So it's S plus burned in air. Here's something very important. Air. What? O2. If they ever say air, I realize that there's more than just oxygen in an air. But the key word here is burn. What can you not have fire without? That's why it's oxygen. It's because it says burn. If you put nitrogen in, okay. So if they ever say air, it's oxygen. So O2. Now, what's this turn into? SO2. SO2. Here's the crazy part. If you would have put an 8 right here, They actually didn't balance it. That's how they left it. It's weird. It's strange. Why? I really don't know. I don't think, because let's see, if you were to balance it, it'd be 8, that'd be 16. That's it. You're done. If you do the 8, I would do that. They can't count that wrong because technically that's right. But they didn't put the 8s, and I don't know why. For some reason, they didn't put the 8s. I don't know why. All right, so let's look at the honors version of this next one. Again, and I like the honors version because I think it really gives you the chance to understand, to grasp where some of this stuff comes from and how you get to the net ionic. So, solutions. Keyword there. Solutions. So is there anything... Well, but let's write the honors first. So we're going to be able to cancel some stuff out. Silver nitrate. What charge is silver always? 1 plus. Okay. And sodium chloride. I hope you can already see what's fixing to get canceled out of this thing. Sodium nitrate. That is the easiest problem I've ever seen in my life. So let's continue just to make an effect. Okay. This right here is the definition of what soluble is. It's a nitrate and it's a group 1. So we can cross out the nitrate, cross out the group 1. So this should have been the answer you should have put. Ag plus Cl minus goes to AgCl. This is what every teacher who teaches solubility rules in net ionics starts off with. That basic. I mean, I really think the more and more you practice this, when you get on the AP exam, I really think y'all have a chance to just rock this question out. And if y'all are making 9 and 10s on the net ionics, you've got a good shot at getting to 3 if you can pull some points together from other places. I really mean that. Okay. This time. Solid. What are you going to do with the solids? Circle it. Iron 2 sulfite. This is a tricky one. Why? Sulfite. What is sulfate? What is sulfate? So what is sulfite? SO3, 2 minus. All right. And it's iron 2. So FeSO3. Again, this is sulfite. Is heated. So what's going to happen to it? It's going to dissociate or decompose. And again, if you want to put that in there, that little triangle tells you it's going to break up. This is one of those other weird ones. This is a metal what? A what? Now, I know I'm writing sulfate, but essentially, isn't it a metal sulf of some type? Does that make sense? Sulfate, sulfite. What it makes is a metal oxide and a sulfur gas. A sulfur oxide gas. It is, and that's kind of, it's a sulfur oxide gas. And the reason I'm saying a sulfur oxide is because one of those oxygens is going to hang on to that Fe. That Fe is just holding on for dear life to hold on to one of them. So now, we know it's Fe2, so you're going to get FeO. Why is it FeO? FeO. No, not ugly. FeO, iron 2 oxide. Where'd the 2's go? Negative 2 and positive 2. And a sulfur oxide gas. So what is your sulfur oxide gas going to be? Well, one of the oxygens hung on to iron. So how many does that leave you? Leaves you 2. So it's SO2 plus SO2. Is there anything to cancel out of this? Is there anything to cancel? Nope. That's it. That would be your answer. Yeah, very good. If it was iron sulfate, this would be a 4. It would still be this, right? But this would change to SO3. If it was hypersulfate, this right here would be a 5, and this would be a 4. If it was hyposulfite, it would be it would be SO2. Yeah, SO2, and this would just be SO. There would be nothing there. Again, running up and down, same deal. And I'm going to leave the last few for y'all to work based on time. What I want to do is I want to cover the one that was in the AP exam this past year. It's the AP exam of this past year. And the reason I want to cover it is because it has qualitative questions with it. And I want to look at as many of the qualitative questions as we possibly can. So give me a second. Let me pull it up. This is what they took last year. So what are the chances of you seeing this exact question again?
100%.
None. You will not see these questions. So yeah, right. Every teacher showed their kids this problem. I can guarantee it. So, but the deal is that we just want to see what happens, and let's see what they saw, and let's see what type of qualitative questions that we can come up with based on this. So, a piece of solid strontium carbonate. So let's write the high school formula for this. So strontium is not St, it's Sr. Now, strontium, what group is it in? 2, and what's carbonate's charge? 2 negative. So you're just going to have SrCO3, and it's mixed with what? Hydrochloric acid, correct? Now, what's wrong? No, we're writing the honors equation first, okay? So, I told you this earlier. This right here has something special that it does. What do carbonates decompose into? Very good. CO2 and water. So what we're going to get over here is we're going to get CO2. And again, that's just something you have to memorize. You have to know that carbonates always break down into CO2 and water. Look at some. Okay. Okay. All right, so what's going to happen is that, look, that this H is going to go here, and this SR is going to go there, right? Swap places. So what are you going to get on the other side? Very good. SrCl2. SrCl2. Huh? We're going to get there. Okay. Oh, I know what happened. No, I know what happened. Whenever I'm recording and I change the position, it takes a huge long lag and delay, and then it'll go back. All right. I know it's nuts. So, there's some things we can cancel. What are some things we can cancel? We can cancel the Cl, and we can cancel the Cl. So, no. It's still there. It's still there. Okay? So, because look, it went from a compound to an ion. Because this is solid. Very good point. I know it's there, but this is a solid. And it went from a solid to what would this be? Aqueous. Very good. And so it went from locked in a solid compound to aqueous. So you're looking for charge changes and states of matter change. You with me? So it went from a solid to an aqueous, so it's got to stay. Again, charge change and state of matter change. So let's write the reaction. So it would have been SrCO3 plus what? H plus. What happened to the Cl? It went away. And then now we have CO2 plus H 2O, and what will be last? SR2 plus. Do what? Got balance. Very, very good. Yeah, let's balance it. All I need is a 2 right here, correct? That's it. Now, I just want to do this because I want to make a point of emphasis. What state of matter would this have been in? Solid. What about that? That's an acid, so it's aqueous. CO2 is a gas. This wasn't liquid. This was a gas, and this was also aqueous. And I did that for a reason, and let me show you why. Look at the question in the indicate one thing that would be observed as the reaction occurs. Joey, very well done. Why is it bubbles? Because there's 2 gases being produced. You went from an aqueous, you dropped a solid down in it. There are 5 signs of a chemical reaction. Bubbles, color change, heat and light, rust, that's the 6th. Solid precipitate, and I just went blank on the other one. Again, bubbles is one of them. Bubbles is one of them. So that's exactly what would have occurred here. Now, if you did not know the rule about carbonate, would you have been in trouble? Absolutely. If you did not know the rule about carbonate, you would have been in big trouble. So carbonate always breaks down into CO2 and H2O. All right, let's look at the next one. Might have to pause the video to slide it down. Okay, so this time, magnesium metal is strongly heated in oxygen gas. So now, metal tells you what? Solid, and then gas also. So we're looking for solids and gases. So magnesium is just straight Mg plus what? O2. What you think you're going to make? MgO. Yes, ma'am. Hey.
Well, I was at another meeting.
The 3 sheets are right here that we're working on. I'll tell you what. Yeah, we've already. That's fine. This one I'm actually pulling from. This is the. This is last year.
I watched one of your videos last night, and the audio didn't play.
Yeah, it was question 1. It's.
I copied the stuff.
So we have MgO. So this is what we'd have. Can you cancel anything out? Now look. Yeah, I know you got to balance it. This went from. Okay, I'm gonna have to pause it now. This went from neutral to a 2 plus. This went from a neutral to a. So did states of matters change? Yeah, because this was a solid, this was a gas, and now this is aqueous. So we have all those, and so a change in oxidation state and a change in states of matter. And now, last part, is it balanced? Nope. So I need what? 2 here, 2 here. This is this is not on what I gave you. This is last year's questions. This is last year's questions. Guys, I've already answered part II for you. Please don't miss oxidation states. What is the oxidation state of magnesium before the reaction? 0. And what is the oxidation state of after? Guys, that's easy. That's honors level. Sir. Technically, I'm trying to think if that would be aqueous or solid. And when I said aqueous, I said, eh. But regardless of whether it's aqueous or a solid, does it still change charges? Yes, it still changes oxidation states. So either way, no matter what, and that's why, honestly, don't put unless it says gas or solid. If you're unsure, don't even put it. Aqueous are ions. Liquid is a liquid. I really don't know the way to explain it. Because it's more of a covalent. Aqueous has ions in solution. It's the ions in the liquid. The liquid is the pure form. It's the pure form of it. Okay, so I'm going to move on to C. And I'm going to have to pause the video to move this. All right, so last one. A solution of nickel 2 chloride is added to a solution of sodium hydroxide, forming a ding, ding, ding keyword. So precipitate. We're looking for a solid. We're looking for something that turns into it. So as soon as they say solid, you're going to know that you're going to have to get something that's a whole compound. You're going to have to get something that creates it. So let's start with how we always want to start, the easiest way. Write the honors chemistry equation, and let's cancel from there. Nickel 2 chloride. Please tell me you can get this. Wow. Is added. Again, let's write the honors version of sodium hydroxide. NaOH. And it's going to go to a precipitate. Now, what type of double replacement type of reaction is this? Double replacement. Thank you. So we have nickel hydroxide being formed plus NaCl. NaCl. So hopefully you can see something. Now, what did they say was formed? Please tell me you know it's not salt. Which one is it? Hydroxides are always insoluble unless with group 1s or ammonia. All right? So this turned into a solid. That fell out of solution. How could you get that if we were making the solution? How could you take that out of solution? What's that word called? When you take a solid out of solution? Filter. Exactly. It's a coffee filter. Exactly. So you filter it out. Now, honors. Let's jump into AP. What do you do with this thing right here? Get rid of that. That's group 1, and it's a chloride ion. So if we cross it out over here, what must we do here? Now let's talk about why. This said solution and solution. So what state was that in? Aqueous. What state was this in? Aqueous. And then ding, 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 we have a solid. So did Ni change states of matter? So we have to leave it, right? You with me? Now, hopefully you know this. What can we cross out right here? Na is group 1, and it went from an aqueous to a what? Because this is also going to be aqueous. Plus this is a strong base, so you get rid of it. You always write the ion of a strong base, right? Okay? So now, we've crossed stuff out. We've got our solid. So let's write the AP net ionic. Ni. Now, can you leave it like this? If you left it like that, that's telling you it's a metal. It's not. It's a what? It's the ion of 2 plus OH what? Minus. And then write your whole solid. Ni. OH2. Again, I'm going to write this out here to the side. Atoms of charge. We want to balance those things. So I have 1 Ni, 1 Ni. 1 OH, 2 OHs. So guess what I've just done? I balanced my atoms. Okay, charge. I have 2 positives and what? 2 negatives. And so that turns out to be neutral. Over here we are neutral. So I'm done. Okay, so let's look at the qualitative question. If equal volumes of 1 molar nickel chloride and 1 molar sodium hydroxide are used, what ion is present in the solution in the highest concentration after the precipitate forms? Think about that for 1 second. Okay? If over here you have a 1 molar and a 1 molar. You with me? Okay? And then I get this thing. First of all, for every one of these, it takes how many of those? Let me do this again. For every 1 nickel it takes 2 hydroxides. So which one is going to decrease faster? It takes 2 hydroxides for every 1 nickel. So, okay, this is how we're going to do it. I'm going to give you 1 penny, and every one I give, you give me 2 back. You don't like that, do you? That's exactly what's happening, okay? So who's going to run out of money first? You are. So who's going to have the highest at the end? Ding, ding, ding. The nickel ion will be the highest. So always look at the ratio of whichever. What if they would have been 1 to 1? What would the answer have been? They would have been the same. Well, since it's 2 to 1, this one's going to run out faster. So you're going to have higher after it's formed. Okay, we go with that idea? Common sense, guys. I mean, that's easy. I want you to think through those things. It's not a difficult task. It's not hard. It's just using your knowledge base, and it's thinking analytically versus quantitatively. Okay, you just got to analyze. You just got to think, and I think you could get this. Any questions? I want to see if there's one more I want to do just based on what I have. Okay, I'm gonna do one that we did today, and I want to see if you actually remember it.
The answer is 4.
No, the answer is not 4. And I'm gonna be honest with you, I messed it up, and I don't know how, but I did. And it's C. No, it's this. Yeah, I'm doing C. I want to do C. It's C. Boron trifluoride. What's that make? We should recognize this. This is boron with a halogen. Remember, BF3 was the most famous Lewis acid. Very good. That's why I want to go ahead and do this one, because I wanted to show it to you. This is Lewis acid. Now, I wrote that wrong today. That's why I want to go back and fix it. So boron trifluoride gas mixed with ammonium gas. And so plus NH3. Now, what is that thing? Remember, it has that extra pair of electrons right there? So it's a Lewis what? Yeah, it's a Lewis base. I think I'm going to start writing NH3 like that. Why? Just that way you know it's always got that extra pair of electrons. What?
We have 1 more day left in here. Why are you going to start writing like that?
That's forever, Joey. That's not just for you guys. So we saw how this forms when this makes something. It's that big ugly word. And I'm just going to write it right here. It's a coordinate covalent compound. Now, guys, I really am going to be honest with you. I don't think and don't know how they would expect you to get this how they wrote it. I'm going to show you how they wrote it, and I think I get it, but I'm not sure. Is it? Oh, no, what you did say is right. And I'm going to show you why I think it's that way. This is what they have. F3B NH3. Well, what I wrote earlier today was this. And the reason they wrote it like that, I think, is because that's how it bonds. Let me show you what I mean.
Well, it doesn't matter how you write it. It all has the right things in the right places.
I'm with you, just like acetate. There's 3 different ways to write acetate. If you write this, I bet they'd give you credit for it. But let me show you what I mean. Because, as a matter of fact, here are... I wouldn't, just because it's not acting as the cation, it's acting as the anion. So this is why I think they wrote it like this. Because look what happens. This B is doing what with the end? It's bonding. It's sticking at that point. So this is F3, and then you have B, and it's stuck to NH3. You see what I'm saying? I think that's why they wrote it like that. It is. It's essentially kind of how it sticks. That's why acetate is drawn or written 3 different ways. Is because there's 3 different ways it can bond. And so I would 99% say, again, I'm not grading them. They would give you credit for how I wrote it. NH3 BF3, sir. Yes, hybridization. They'll never give you anything crazy like this. Ever, ever, ever. Okay. Ever, ever, ever. All right, let's do one more. And I want to do E. I want to do E. Right here. Yeah, absolutely. Let me do this one, Jen, and then you can have it. Okay, so let's do E, guys, and we'll call it quits. E. Dang it. There we go. All right, so E. Keyword, what is it? Solid. Ammonium chloride. So let's write the honors version. NH4Cl is added to a solution of potassium hydroxide. So plus KOH. So what type of reaction is this? Try again. Double replacement. You have 2 compounds. So NH4 is now going to be with OH, and K is now going to be with Cl. So let's look and see what happens. So we have NH4OH plus KCl. Now let's see. What can I cross off first? I can no. Here's why. Let me throw this at you. What does that say? Solid. So since this is a solid, this turned into what? Aqueous. So what has to stay? The Cl. Why does the Cl have to stay? It changed states of matter. It went from a solid to an aqueous. So the only thing we can cancel is the K. So the only thing we can cancel is the K. All right. The only thing we can cancel is the K. So far, for the AP version, we can write the reactants. NH4Cl plus OH minus. And we know we're going to get a what? Cl minus. Because remember, it's an ion form. You with me? You cross off the K, you got to get an ion. This is where I wanted to show you this, because I don't quite know why and how it happened. That's exactly what it made, Taylor. Why? This right here splits into NH3 plus H2O. Why? Taylor, you said it. Why'd you say it? Anytime you react with a hydroxide, you produce a water. If you ever react with a hydroxide, you ever have one of these on the reactant side, you gotta have one of those on the product side, or vice versa. Because this is a salt. Recognize it? What type of salt is this? NH4 came from a, try again, weak base. HCl came from a, so this is a acidic salt. It's that NH3 and NH4 plus just is one of those I personally don't understand. NH4 is the conjugate acid. but it can also act as the base. It's amphoteric. Yeah, I know. It's, sir. That's ambidextrous. There's no oh, I forgot the plus. Sorry, there is a plus right here. Forget. Yep. Well, yeah, it's there to there. All right, last question. Is it balanced? Charges? Yes. Any questions? This one is really weird because it's propanol. I'll give you the formula for propanol if you want to see if you can do it. Oh, it's a combustion reaction. What does burned in air mean? In oxygen, burned in air. All combustion reactions produce CO2 in water. So propanol, again, you probably wouldn't know this. Is the anol turns it to an oxygen base. No, it's C3H6O. And again, I hope you do know this, that in organic nomenclature, prop, right here, P-R-O-P, stands for 3 carbons. Meth is 1, eth is 2, prop is 3, bute is 4. And then it stays normal after that, pent, hex, hep, oct, non. So meth, so if it's methane, how many carbons? 1. If it's butane, how many carbons? 2. Do I would know the prefixes at least. Propane is 3. No, I screwed that up. Yeah, butane is 4. I'm sorry. It turns it into an oxygen bearing. Sorry, this is eth, not bute, and then bute is 4. It's like butanol. Butanol is C2. Yeah, butanol. There's 2. Bute is 2. Dang it, 4. Crap. I am messing it up. So bute is 4. So it's C4. Nope. Double minus 1. No, that is double.
What is anol?
Butanol. That would be butanol. That's what you would put in a car. Like there's ethanol that goes in a car, right? It turns into an alcohol-based deal because that's an alcohol.
So anol shows
You add an oxygen.
or just OH.
Huh? It's just an O.
Just now. Okay. So that was just thrown in there just to be thrown in there.
Well, it's that anol turns it into the O. Like methane, methanol. Methane has no oxygen. Methanol adds the oxygen. Like methylamine.
So
Meth is 1 carbon. Amine is a totally different attachment. There's a nitrogen base attached.
if it has all in it, all we have to do is throw in the 0. I mean the oxygen.
Yep.
So it's
All right, so hopefully this has helped as far as net ionics. And it's not balanced. It doesn't even have it balanced on here. They do. It's not balanced, but it's not balanced on here. So y'all can figure out how to balance it, but I hope this has helped.